So for today, we are going to look in the area of science called chemistry. And under chemistry, we are going to look specifically at something called elements. So what is element? Everything in this world, is made out of something, made out of substance. So be it the air that you breathe, water that you drink, or even the pen or pencil that you use, they're all made out of substances. So an element is actually the simplest substance that cannot be broken down further. So what do we mean by this? Let's look at an example of, say, water. So many people know that water is also sometimes referred to as H2O. And why is it so? Because it's actually made up of elements hydrogen and oxygen. So as you can see, water itself can be broken down into 2 units of hydrogen and 1 unit of oxygen. So water is not an element, whereas hydrogen itself cannot be broken down. The H cannot be broken down to other elements. So you can see that these two are elements and they have their own symbols to represent these units. Another example is maybe look at air, the air that you breathe. So air is actually made up of a lot of different gases. For example, oxygen. We need this to live. You even have hydrogen and even have carbon dioxide. And even these elements, even these components, not all of them are elements. So oxygen is their own element, it has their own symbol. Hydrogen has their own symbol. But carbon dioxide is actually a compound that we'll go through later, and it actually has the symbol of CO2, carbon dioxide. So you can see that carbon dioxide is not an element as well. So air, which is not an element, is made out of different gases, which not all of them are elements as well. Carbon dioxide is actually made out of carbon, which is the element, and also 2 units of oxygen, which is the element. So 2 things you have to note about elements. One, elements have symbols for themselves. For in this case, like I mentioned, oxygen is O, hydrogen is H, you can see here carbon is actually C, and yeah, so these are the 3 examples we used just now. The second thing you need to know about elements is that they have 2 different groups. It can be broken down to 2 different groups, and they are metals and non-metals. And these 2 groups have both very different properties. Things like their densities. For metal is higher density, and non-metals have lower ones. And things like even conduction. It's a good conductor of heat and electricity. And non-metals are not so good as a conductor of heat and electricity. So there are a couple of other different properties, and you will have to remember them. So next thing we're going to look at is periodic table. So I'm going to draw out the periodic table. So, and here we have it. Sorry that it's drawn like this because I had to draw it freehand. The actual periodic table looks a lot nicer when it's printed. So this periodic table lists down all the elements in the world, and also they have the chemical symbols that we mentioned about within the individual boxes in this periodic table. So a couple of ways to read this periodic table. So first, we have something called groups. So groups are the columns that you have on the periodic table. That means from up to down. So this is group 1, this entire group, this entire column is group 1. You have group 2, group 3, all the way up to groups 7. Yep, that's 7. And then finally group 0. So these are the columns of the periodic table and also the groups of the periodic table. So the other way you can read it is through the periods. So the period is how you read from the left to the right of the individual rows. So this would be period 1, period 2, all the way to period 7. So when we say, for example, period 3, we will mean that all the elements on this row. And if we say, for example, group 3, we mean all the elements up to down on this column. So this is what we mean by group and period. And actually they have some significance as well, as in terms of the elements in the same group, they will actually share similar properties. For example, all the elements on group 3 will actually have very similar properties amongst the elements here. And how you read the elements in the period. So all the elements as within the example period 4, you will have metallic properties here, and as you go down the row, you will have non-metallic properties here. So this will have, the early ones would have very metallic properties, and as they go further down, they will lose their metallic properties, and they will appear to have more non-metallic properties, and eventually come to all the way to the right, where it will be a non-metal. So this is how you read the periodic table. So we are now going to look at compounds. Let's rub this away. Go. So a compound is a substance that consists of 2 or more chemically combined elements. So the keyword here is actually, it has to be chemically combined. These elements have to be chemically combined. What do I mean by this? So for example, I have a bag, and I put in oxygen, and I put in hydrogen. So is this actually a compound? Actually they are not. It's just a bag of oxygen and hydrogen, which is a mixture, which we'll go through later. But a compound has to be chemically combined. So, and how does this process work? So you have to give it some sort of energy. For example, water. We know that water is a compound because it's chemically combined. So how this is created, you can actually have hydrogen, 2 units of hydrogen. You have a unit of oxygen, and you give it energy. And energy can come in the form of heat, or it can come in the form of light. So as long as you have enough energy, you can actually create a chemical reaction for the hydrogen and the oxygen to bond and create water. So likewise for compounds, for example carbon dioxide, it can be separated into carbon and oxygen by using energy, by putting energy and causing a chemical reaction. So this is how compounds work. They can only be broken down by such chemical reactions. So a couple of things to note about compounds. They actually have very different properties from the element. For example, water. You kind of you sort of know that they have very different properties than with oxygen and also with hydrogen. And if you have the different masses of the elements, if you add them together, you will get a proportionate amount of the final element. For example, if you have 4 grams of hydrogen and say 2 grams of oxygen, what you'll get is actually 6 grams of water. So it's you don't lose any if it's in a controlled environment when you do this chemical reaction.